All right, I'm going to try again. This is my second take on this video, y'all. The first one, the graph looked so bad, so I had to redo it. All right, so this is hyperbola. And the first thing you want to do is figure out, is this thing opening left, right, or is it opening up and down? So we look for the fraction that is positive. So the one that doesn't have the minus in front of it. And that is the x fraction. Now the x-axis runs horizontally, left and right. So your branches are going to be opening left and right for that reason. All right, so we've decided that. Let's go ahead and figure out what our center is going to be. But before we even do that, we can determine what A, B, and C are. So A squared is going to be on your fraction where your x is, because according to the format, that's just how it goes. Your positive fraction has your A squared value on the denominator. So A, if A squared is 25, then A is 5. Similarly, if B squared is 4, then B is 2. Now for C, that formula is on your reference sheet. It's A squared plus B squared, and that will end up being 25 plus 4, that's 29, which is about 5.4. So here are our values. They're going to help us to draw this graph. Before we do that, though, we need to base everything off where the center point will be. And remember, your HK comes from your stuff in parentheses up here with X and Y. So H will be a -3 and K will be -4, and there's your center. So I've already got that plotted right here. It's a little bit harder to graph when you're standing to the side of a graph, so that's one reason why I'm having to redo this. So if I have to step in front of the screen for just a second, that's why it's hard to graph it when you're standing beside it. And actually look right. Actually, I think I need to redo this again. All right, so there's -3, -4. All right, if we know our A value is 5, then that means from the center, we need to go a distance of 5 units to the right and to the left of the center point, because it is on our x fraction. So it's a horizontal distance, A is. All right, so here we go. 1, 2, 3, 4, 5. So we're right here at 2. And we're going to go back 5. So 1, 2, 3, 4, 5. So we're here at -8. All right, that's your A distance. That's A. All right, now let's go our B distance, which is 2 from the center. And we're going to go top to bottom, 2 units. So up 2 units and then down 2 units. Okay, and that's your B distance. So there we go. All right, now that really just gives us the dimensions of this rectangle that will actually help us later figure out where the asymptotes are for this graph. So what we want to do is we want to draw a rectangle with those dimensions. So I'm going to extend a line horizontally here until I get on level with that point, go down, and it looks like it bottoms out here at -6, come back over here, and meet up this other corner. All right, so there is our rectangle. Then the next part we need to draw in is our asymptotes, which are technically just the lines that pass through the rectangle that are its diagonals. So it's also going to pass through the center. So we're going to extend those past the rectangle. This way, draw both of them. All right, so there are your asymptotes for your rectangle, which is actually the asymptotes, or just the diagonals, and it will help you form the branches of the hyperbola. So we're ready to actually figure out what the vertices are. Now the vertices will be where A is marked off on to the left and the right of your center. So that's where the branches are going to intersect that rectangle. Draw with red here. So here is one of the vertices, and here's one of the branches. We're going to keep it between those asymptotes on both sides. Here's another vertex. Keep it between the asymptotes as best as you can. All right, so in terms of coordinates, we can just look at the grid to identify those. It looks like one of them is going to be at 2, -4. And then it looks like the other one is going to be at -8, -4. Okay, so those are the vertices. Then what we want to do is go ahead and figure out where the focal points would be, also known as the foci. We use this little formula to find our C value, and that will help you actually to figure out where those focal points are going to be. So C is the distance from the center to the focal point, and it has to be on the same axis as your branches, okay? So we're going to count 5.4 units from the center to find the focal point to the left and to the right. So 1, 2, 3, 4, 5, and a little bit more, 0.4 more will be one of the focal points, and then we're going to go by this way. 1, 2, 3, 4, 5, and a little bit more. So you're just estimating on those. So there's one focal point. Here's the other. Where would those be in terms of coordinates? Well, technically you could just add and subtract that 5.4 from your x-coordinate of your center, and that's where those points are going to be. Or you could just look at the grid and count. So it looks like this would be 2.4, -4. The one on the right here, the second one. And the first one's going to be at -8.4, -4. All right. So again, you could just add and subtract that value to your x-coordinate, and that's going to give you the same thing. Or just count on the grid. All right.